I'm Anil Kumar. Welcome to my series on calculus. In this video, we are sharing questions from previous test paper. In part 1, we have done questions 1 to 4, and now we'll take up 5 to 8. So these are the questions which we have already done in part 1. And now we are going to take question number 5, 6, 7 and 8. Right? You can always pause the video, answer them, and then look into my suggestions. Question number 5 here is, a conical tank is being filled with water at the rate of 2 pi meter cube per minute. The radius at the top is 4 meters and its height is 8 meters. How fast is the water level rising when it is 5 meter deep? So let's make a rough sketch. So that's the kind of cone which we have, and says that the rate at which it is being filled is 2 pi meter cube. So that is the volume, right? So dv dt is 2 pi meter cube per minute. The radius at the top is, so the radius is 4 meters. So this is 4 meters. And the height is 8. So if I take a cross section, then we could actually do it like this, that 4 and 8 is the total height. How fast is the water level rising when it is 5 meter deep? So 5 meter deep, let's consider as, so we want at this stage, how fast is the water level rising, since we are pouring in water at a given rate, right? So that's the question. So I hope the question is absolutely clear. Wherever there is a conical tank or a flask included, we have to do similar triangles, right? So from similar triangles, you can see that the ratio of height to radius is same, right? So radius to height, the ratio here is radius is 4 and height is 8. So that is going to be maintained. So this relates height and radius. We need to find how fast is the water level rising when it is 5 meters deep. That means we need to find dh dt, right? So we need to find dh dt. So we'll write radius in terms of height, correct? So let's develop the relation which is going to help us solve the question. Volume for a cone is 1 by 3 pi r square h, correct? And from here we know that r over h is 2, right? R over h is 1 over 2, right? So it's half. So we can write what is r in terms of h. So this gives you r equals to half of height, correct? So replacing that, we get the volume as 1 by 3 pi h by 2 whole square times h, or you can say volume is 1 by 3 pi h square times h is h cube, we can write, and 2 square is 4. Okay? So we have volume as 1 over 12 pi h cube. So differentiating volume with respect to time, we get this as 1 by 12 pi times 3 h square dh dt, correct? So that is the expression which you get once you differentiate this with respect to time, right? We need to find the rate of change of height when the height is given to you as 5 meters. That's what we need to find. Is it okay? So we need to find what is dh dt when h equals to 5. We know dv dt is 2 pi, so we'll substitute these values, isolate dh dt. So we can from here get dh dt as equal to, now you can simplify this, dividing this, we get 4 here. So So cross multiply. So we get 4 in the numerator. The denominator is pi h square dv dt. Correct? So now dh dt for height equals to 5 will be 4 over pi 5 square, and dv dt is 2 pi. So that becomes the value. So 8 over 25. Units will be, we want to find rate of change of height in meters. Meters per minute. Is that clear? So that is how we are going to answer this particular question. Now let's take up the next question, which is question number 6. A point moves along a curve y equals to square root of x square plus 1 in such a way that dx dt is 4 units per second. Determine dy dt when x is square root 3 units. Right? So we are given y equals to square root of x square plus 1. We are also given that dx dt is 4 units per second, and we need to find what is dy dt when x equals to square root of 3. Right? So let's find the derivative here. So we get dy dt equals to what? Dy dt is equal to, now that is to the power of half, so it will be 1 over 2 square root of x square plus 1 times derivative of inside function, which is 2x times dx dt, right? Since we are differentiating with respect to x. Now to find dy dt at x equals to square root of 3, we know all these components, so it is easy to calculate, right? Just substituting the values, we get our answer. So we get dy dt at x equals to square root of 3 should be equal to 1 over 2 square root of 3 plus 1 times 2 times square root of 3, and dx dt is given to us as 4, correct? So that is what it is. We can simplify this and then write down our answer, which is, this is square root of 4, which is 2, right? So we'll just do it in 2 steps. We get 4 square root 3 over square root of 4, which is 2. So we get 2 square root 3 as our answer, and dy dt will be units per second. Correct? So in our case, the answer will be 2 square root 3 units per second. Question number 7. The surface area of a closed cylinder is given by A equals to, let's write down the formula, 2 pi r square plus 2 pi r h. H is the height and r is the radius of the base. At the time that the surface area is increasing at the rate of 20 pi centimeter square, so surface area is increasing, so dA dt at 20 pi centimeter square per second. The radius is 4 centimeter. We are given r is 4 and the height is 1, and height is 1 centimeter. And the height is decreasing at the rate of 2 centimeters per second. So we are given dh dt seconds. So write minus 2 centimeters per second. Determine the rate of change in radius at this time. So we have to find rate of change of radius at this time. Right? This is what we need to figure out. Now we have the expression. We can just find derivative with respect to time. So we get a equals to 2 pi r square plus 2 pi r h. dA dt will be 2 times 2, 4 pi r dr dt plus, Now here, both R and H are changing, right? So we'll have to use a product rule in this particular case. So we get 2 pi is a constant, right? And R and H. So if I have a derivative of R, it is dr dt times H plus R times dh dt. Is that clear to you? So that becomes the rate of change of area at a given time. We need to find what is dr dt, right? So that's what we need to find. So we can always isolate that, or we can just let's isolate. That's not a problem. So we'll write dr dt. So here we have 4 pi r, and here dr dt is 2 pi h. The other term is 2 pi r dh dt, right? So plus we have 2 pi r dh dt, correct? So now from here we can get what is dr dt equals to. So dr dt is equal to dA dt minus 2 pi r dh dt, correct? And we'll divide all this by 1 over, that is multiply with 2 pi r plus 2 pi h, 4 pi r plus 2 pi h, correct? Let's see value. So dA dt is given to us as 20 pi. So we have 20 pi minus 2 pi r dh dt is minus 2. So minus 2 divided by 4 pi r. R is given to us as 4. I should have written 4 here for r also. So r is given to us as 4. So 4 times 4 is 16 pi plus 2 pi times h, and h is given to us as 1, right? So times 1. So that's what we have. Now pi is common, so let's just cancel pi from all the factors, and then we'll simplify this to get the result. So we have 20 minus and minus becomes plus, and 4 times 4 is 16. So 20 plus 16 is 36 over 16 plus 2 is 18, and so we get 2. Correct? So dr dt is 2, and the units will be centimeters per second. So let me write down here dr dt is equals to 2 centimeters per second. Is that clear to you, right? So you may have to rearrange or things like that, but you could substitute the values directly and then isolate dr dt to find the result. Don't forget to apply product rule at this stage. So I hope that makes sense. Question number 8. The ends of a water trough 1 meter long are equilateral triangles. Water is poured into the container at the rate of 20 centimeter cube per second. Find the rate of change in the height of the water when the height is 10 centimeters. Okay, so basically we have a triangular section which is kind of like this. Let's just make one triangle here, and that is the top, right? So it is again triangular like this. So let me just sketch a triangle here. Parallel side, so that is on the bottom, right? Let's say like this, and this is kind of like this. So that becomes a triangular trough. Now in this particular case, what we need to relate is height, right, with the area of this triangle, right? The ends of a water trough 1 meter long, so we are already given that this length is 1 meter, which is 100 centimeters, correct? Water is being poured at a rate of, so change in volume is dV dt, which is 20 centimeter cube per second. Find the rate of change in the height. So we need to find what is dh dt when the height is 10. So basically we need to find expression for volume. That is the first thing. So area of an equilateral triangle, let's figure out that first. So let us say this is the height. We are given that the angle here is 60 degrees. Correct? All sides will be equal. So let's find what this side will be. So let us say this side is S. In this case, side S over, that is the hypotenuse, correct? Side S is the hypotenuse which we need to find. So we know that sine, this is opposite side, correct? So we can say sine of 60 degrees will be equal to opposite side over the hypotenuse, so h over s, correct? And in an equilateral triangle, you know the ratios. Let's sketch one here on the side. This is half of the equilateral triangle, which I normally use. So that is 60 degrees. So 1, 2, square root 3. These are the ratios of the sides. 30, 60, 90 triangle, correct? So sine 60 is square root 3 over 2. So you could write this as square root 3 over 2 is h over s. So each side length, you can now write that each side length s is equal to 2 over square root 3 times height. Is that clear to you? Right? So that is a relation which is well known and should be very clear in your mind before you start doing this question. So that gives us the formula for area, which is half base into height, correct? So we get the volume as equals to area is half, base is S, right? Which is all this, which is 2 over square root 3 h, that is the base, times height times the length, which is 100. Is that clear to you? So that becomes the formula for the volume, which is basically area of triangle times length. So for any particular height h in general, that is going to be the relation, because it's going to be equilateral triangle all the time, correct? So I hope this part is clear. So first thing is to get the volume. So this 2 and 2 cancel, and we have h square over square root 3 times 100. So that becomes the volume. Now, rate of change of volume with height will be dv dt, and this will be differentiating both sides with reference to time, correct? So we get 2h dh dt, correct? As far as the constant is concerned, it is 100 over square root 3. Clear? Now from here, we can easily find what the rate of change of height is, which we are interested in finding. And when h is 10, correct? So we can just substitute these values. So we can isolate dh dt. So we can say that, let's do it on the right side. So we have dh dt, rate of change of height is equal to, that square root 3 will come in the numerator, over 200h. Correct? So times dv dt. Right. Substituting the values, we get dh dt for height equals to 10. So it will be square root of 3 over 2000. dv dt is given to us as 20 centimeter cube per second. We'll just multiply by 20. Right. So that goes 100 times. So basically square root 3 over 100. And the units are going to be centimeter cube, centimeter per second. So that's how we're going to get our answer. So our answer is square root 3 over 100 centimeters per second. Is that clear to you? So I hope with this you understand how should we be solving questions based on rate of change, correct? So in this video, we took up 8 questions from previous test papers. So that is the variety. If you are working with this video, you should be in a position to get good marks in your test on related rates. Perfect. So these were the 8 questions which we just did. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.